All right, so here we are, lesson 3 of Unit 10, PSC 1. Today we're going to explain similarity shortcuts for triangles. Okay, so in order to prove that two triangles are similar, what two things do we have to know about them? Talked about this yesterday. Sides are proportional, correct? And what else did you say? Angles congruent. Okay, so let's have a little conversation about that for a moment. How many sides are there in two triangles? 6. So there's 3 pair of sides, right? So we'd have to check 3 pair of sides. And we'd have to do something like this. And we'd have to see if each of these said items were proportional, so to speak. There might not be letters in there. There might be numbers. And then we'd have to look at all the angles, which means we have to look at 3 pair of angles as well. And check that those are congruent. So there's a lot that goes into that, but we can actually shorten that up. So we pose a question here at the bottom of this slide, and it says, are there shortcuts? In other words, could we determine the triangles are similar without knowing that all 3 pair of corresponding angles are congruent and all 3 corresponding sides are proportional? And the answer to that is yes. Here are the 3 ways that we can prove triangles are similar. If 2 triangles, this is all you need, have just 2 pair of congruent angles, we can say they're similar. How's that possible? Well, we'll get to that in a minute. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. I'm going to use this symbol for similar. Okay, so I got the lasagna symbol for congruent and the spaghetti noodle for similar. Okay, we'll get to why in a couple minutes here. Side similarity. If 3 sides of one triangle are proportional to the 3 sides of another triangle, then the 2 triangles are similar. So I can either check just 2 angles, I could check all 3 sides, or the last one, and this is the one that kind of hangs some students up a little bit, is the wording. If 2 sides of one triangle are proportional and the included angle, that means the angle between those 2 sides, are congruent, then the triangles are similar. So side angle side would mean this. If that side is proportional to this side, and this side is proportional to that side, and the angle between them is congruent, then those 2 triangles are similar. We good? Does that make sense? Okay. So I want to do a little demonstration, Miss Ospey. I'm going to use the seat there for a moment to draw something out. Okay. So I like Smart Notebook for this reason and many others. But let's say I draw myself a triangle right here. Let's assume for a moment that this isn't equilateral. Let's say this angle is whatever measure, this angle is whatever measure. I only know 2 angles, right? But if I take this triangle and I shrink it, does anything change with those angles? No. But did anything change with the sides? Okay, so let's say this turned into a half. Did I shrink it proportionally? Yep. So this would still be a half. And this side would be 1. Okay, so that is proof right there that angle works, right? Okay, let's try another one. Let's take some kind of oddly shaped triangle here. Something scalene. Okay, let's see here. Oni, give me 3 numbers, all between 5 and 10, but different numbers.
7.
Okay.
4. 5.
We'll go 4.
And 8.
Yeah.
8.
Yep, works for me. Okay. Let's say I take this triangle. I know all 3 sides, but I know nothing about the angles. Nothing about the angles. And then I expand it. Did the angles change? No. Let's say that I scaled this by a factor of 2. Okay, I'd have a 16, a 14, and an 8. Well, would you agree that those 2 triangles are similar? Right? If all 3 sides are proportional, then I could say that, yeah. The angles are congruent, therefore that's true. All right, and then the last one is side angle side. The one I like to use the most is the right triangle. Not necessarily isosceles, but I'll go with it. Let's assume this angle right here is, hello. I'll just draw it. A right triangle. Okay. And let's go a 3 and a 4. Do I need to know this side length? No. As long as, your name is Elizabeth, but you go by something different. Betsy. Betsy, what's your favorite number between 2 and 8? 6. Okay, so I'm going to make this side 18, even though this isn't proportional, and this side 24. Would you agree this is a 6-to-1? Correct? Okay, so if I have a side, a congruent angle on a side, right, and these are proportional, then these sides should also be proportional. So what should this side be? 30. Yeah, 30. Let's see if it works. Let's see if that worked. I'm going to do Pythagorean Theorem to see if this is a right triangle. Remember this from last unit? Right triangle's 1. 18 squared. Somebody with a calculator. 24 squared. Somebody with a calculator. 30 squared. Well, I know 18 squared. 324? Is that 3024? Is 24 squared, what is that? 496? No. 576. Oh gosh, I knew it ended. Is that equal to 900? 800 plus 100, yeah, 900. Perfect. Check. We just proven it. All right, Elsa, take a look at the next slide. Okay, now I write side-side angle this way for a reason, because in my student teaching we did this and I wrote it the other way around and children started laughing, and I was like, oh yeah, I guess you don't want to spell that word in class most of the time in the 7th grade classroom. They thought that was funny, but side-side angle does not work, because look at these 2 triangles over here. They have an angle right here. They have a side, and both have the same attributes, right? The angles are congruent, the sides are the same, but I can form 2 different triangles out of that, right? Because this side right here doesn't have to be a certain length. It can be shortened and still keep those same attributes. So I like to say, when we talk about similarity of triangles, no swearing. Swearing doesn't work, right? It doesn't work. It doesn't work with similar triangles. Okay. Now, let's talk about a couple of examples of shortcuts. Okay, so we know these 3 shortcuts: side, 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 angle, angle, and side, angle, side. I want to help you with the first couple here. Let's see. Okay, do you guys remember back a little ways inscribed angles? Inscribed angles are always half of what?
Oh,
You're on it.
oh,
Yep, the arc that it intercepts, right? So this arc right here would be double this angle right there, right? There is another angle over here that intercepts the same arc. So what do I know about those two blue angles? They're the same. They're the same. Therefore, does anybody know what these two angles are called? Because they are congruent. Vertical angles. Vertical angles. Okay? Now, if I have two triangles that have angle congruence in two places, that's a shortcut similarity. We know those triangles are then similar. That's as far as you have to go. You don't have to then confirm, ooh, there's a common ratio throughout and all the angles are congruent. That's as far as you have to go. Okay, so I just did less and showed that they were similar. But now I have to find x. Okay, so let's do that. Could we say that these angles are going to be congruent? They have to be, right? If 2 out of the 3 angles in a triangle are congruent, then the other one has to be because those 3 have to add up to 180. Therefore, they would have to be congruent. Now, what would, if I were to write out a proportion, we can agree that 8 and x are in the same triangle. I think we can agree on that. What side corresponds to 8? 6 or 7? 6. Is it true that the side length of 8 is between the blue angle and the green? Yes, it is. What other side length is between blue and green would be 6. So 8 corresponds to 6 in the same way that x corresponds to 7. We've got ourselves a proportion, and we're going to do some multiplicaciones. 8 times 7 is 56. 6 times x is 6x. I divide both sides by 6. And I don't know if that goes into that equally. I don't think it does. 6 goes into 48 8 times. So how about 9 and 1/3? Okay, kind of a gross number, but that's okay. So far, so good? Okay, let's try another one. Okay, typically, if you see congruent angles, it's a dead giveaway. If there's only one pair of congruent angles, there's only one shortcut that involves that. However, we need to confirm whether or not this works. I am tempted to say yes by side angle side. Would you agree? You agree with me? Say, yeah, I think so. Because we know we can check off the angle portion of that because those two angles are congruent. We just have to check the sides that go around that angle. Okay, so I've got a 6.75. What does 6.75 correspond to? 3 or 4? 6.75, is it the longer or shorter of the two sides that surround that angle? Shorter. So 3 is the shorter of those two sides that surround it. And I see that 9 would correspond to 4. Let's see if this is a true proportion. Well, how would I know whether or not it's true? Because I still haven't proven these are similar. I'm going to cross multiply and see if the numbers are the same. 9 times 3 is 27. What's 6.75 times 4? It's 27. It checks. It works. If that were to come out to be something that is not true, then we could not say that side angle side similarity works. So side angle side, yes. Let's solve for z. My proportion for z would be z over 2. Okay, I'd throw that into that triple proportion. Don't be the kid that tic-tac-toes this thing. Someone is going to do this. I think I showed you this yesterday. Someone will do this. 3 times 9 times z equals z times 4 times 6.75. What? Yeah. Do this. Use nice numbers. right? 4z equals 18. So it looks to me like z equals 9 halves or 4 1/2. 9 halves. Perfect. All right, so Sammy is going to do some work here. I'm going to be her, I'm going to annotate and just be her, yeah, go. Sammy, you're up. So Sammy's going to cross multiply. So 30 times 13 is 390. Perfect. And then she's going to write this out with 5 on the outside of the parentheses so that we can see it being distributed. You know what I'm saying? 5 parenthesis. Right? And then 13 plus x on the inside. Good. And then because Sammy knows her, yep, distributive property. Good. 5 times 13. She said 65, and she's right. Plus how many x's?
Oh my God.
Hold on, it's okay. It's okay. Plus 5 x's. Thank you, Wyatt. Old man Smith's in the back. On the left side, we have a 390. And so Sammy is going to do what? Subtract 65 from both sides, which we would get, yep, Sammy, you're absolutely right, 325. That's great. Nice job. She's telling me this, folks, on the web. And when we divide by 5, that should be, I think, 65, right? Yes, perfect. So we have found that x equals 65. Thanks, Sammy.
I don't know how to do the outro. I think we should just do the outro.
Oh shit, what's your channel's name? Oh shoot, I forgot how to do it. Thank you for watching, sisters. Comment, like, and subscribe.
Yeah, say meow.
Meow. Follow me on Instagram. But oh shoot, okay. Just leave it. Just leave it.
Have a nice day.